So hello, my name is Ákos Vida, and I will be talking about robotics, and namely, can they be homemade? So first of all, here's an outline of what I'm going to talk about. First, the applications of the robotics, then my project, and then finally, a conclusion. So I want to clarify that most robots that we know aren't humanoid like a NECA here. Most robots that we know and love look somewhat like this. This, of course, is the humble dishwasher, and these are actually the robots that most of us see. Robots also have plenty of other applications. For example, they are non-sentient. Therefore, they can be put into dangerous environments without having to fear that they actually get hurt. Robots are also really fast and efficient, so they can also often reproduce tasks way faster than humans. And also, robots are purpose-built because humans are really good at surviving, but not many of us have welders for hands, as can be seen on this picture. So my plan is to make a robot that looks somewhat like this. This is a picture of a robot that I found online, and mine has some key similarities. For example, the structural elements are aluminum, and the end pieces are 3D printed. But there are also some key differences. For example, this robot costs $2,000, which is way out of the budget of my project. And so the main parts that my robot has are, first of all, the stepper motors. These are just motors that move everything around. After, there's a Raspberry Pi. This is the brains of the entire project. It's just a tiny computer with the difference that it has little output pins that can be seen in red that it can turn on and off. And finally, not finally, there's a cycloidal drive. This is a gear reduction that slows everything down and makes everything more powerful. And also a big thrust bearing that is at the bottom of the robot, and that is put there to make sure that everything can rotate nicely. So I actually started the project by creating a draft like this. I actually spent a lot of time on this, and yeah. Next on the timeline, I started working on the cycloidal drive, then the wiring, and finally 3D modeling everything, and then 3D printing everything. A really interesting part in the robot is how does the Raspberry Pi computer tell the motors to spin? Because motors want a weird form of current called sinusoidal current, which is just electricity that goes up and down like a sine wave. And the Raspberry Pi can only give a normal on and off current. The solution is to add a stepper driver that can be seen in purple, and that basically gives the motor all the power that it wants based on the signal that it gets from the Raspberry Pi. Also, the motors will not be able to lift anything if there wasn't a gear reduction, in this case a cycloidal drive. Most gear reductions that we know and love look somewhat like this. There's an input gear and an output gear, and the ratio between the two determines how the torque and the speed. But a cycloidal drive, on the other hand, it uses a cycloidal disk that can be seen in yellow to transmit the fast-spinning green input into a slower spinning but much stronger purple output. Also, so the entire robot, besides moving just like this, it also has to turn around. And that obviously needs a bearing. And most bearings that we would normally see are called radial bearings. They're what you would find in a wheel, for example. But if you wanted to make something like a merry-go-round or a robot arm, you need a thrust bearing. And this is a thrust bearing, you can be seeing green, and it's designed to take load from the top. But the problem with this, in my application, is that the two top plates would slip away. So the solution I used is to replace the cylinders that can be seen in the green picture with gears, and everything meshes nicely, and that's how everything can turn. In the end, this is what the robot looks like. It's actually fully functional, which is great news. It obviously has some limitations. For example, there are some mechanical limitations because it's not strong enough yet, and also some electronic limitations because of the electronics involved. But it is actually a work in progress, and it's actually looking really good. I'll actually do a demo in the break, as can be seen right in the back there. So, in conclusion, can In conclusion, I think that robots can really help humanity. They can greatly decrease human workload. And the answer to the big question, can robotics be homemade? Absolutely. This was a project I found really, really fun, and something that I really do recommend to anybody that has an interest in robotics or engineering. But of course, do be warned that there are lots of roadblocks that come along the way, but that also just adds to the fun of crossing them. Thank you very much.